Oh, yeah.
Hello, if you're joining us, we'll get started in a moment, just giving it time for everyone to join. All right. Hello, everyone. Welcome and good evening. Thanks for joining us virtually tonight. My name is Maddie Walters, and on behalf of Harvard Bookstore, I'm pleased to introduce this virtual event with Martin Karplus, presenting his new book, Spinach on the Ceiling, in conversation with John Straub. Through virtual events like tonight, Harvard Bookstore continues to bring authors and their work to you and others in our community during these challenging times. Every week, we're hosting events here on our Zoom, and as always, our event schedule appears on our website at harvard.com/events. You can also sign up for our weekly email newsletter and browse our shelves from home. This evening's discussion will conclude with some time for your questions. If you have a question for our speakers at any time tonight, go to the Q&A box at the bottom of the screen, and we'll get through as many as we can. In the chat box during this presentation, you'll see a link to purchase tonight's book online. All sales through this link support Harvard Bookstore, so thank you for your support during this trying time for community spaces like your local bookstores. You will also find a link to donate in the chat box. Your purchases and contributions make this virtual author series possible, and now more than ever supports the future of an independent bookstore. Thank you for tuning in support of our authors and the incredible staff of booksellers at Harvard Bookstore. We sincerely appreciate your support now and always. And finally, as you may have experienced in virtual gatherings these last few months, technical issues may arise. If they do, we'll do our best to resolve them quickly. Thank you for your patience and understanding. And now I'd like to welcome John Straub before I hand things over. Dr. Straub is a professor of chemistry at Boston University. His research explores protein dynamics and thermodynamics using theoretical and computational methods. He received his PhD from Columbia University and completed his NIH postdoctoral fellowship at Harvard University with none other than Martin Karplus. And on that note, I'm pleased to turn things over to tonight's speakers. John, the digital podium is all yours.
Thanks very much, Maddie, and it's a real pleasure to be here this evening. I love the Harvard Bookstore and I've enjoyed it for decades, and it's great to have this virtual event sponsored by them. Well, it's my pleasure to introduce Professor Martin Karplus, who has many distinctions, including being the author of Spinach on the Ceiling, The Multifaceted Life of a Theoretical Chemist. For decades, Martin has been one of the most talked about individuals in science. Among Karplusians, the more than 250 of us that had the pleasure to work in Martin's group, and non-Karplusians alike. I think this has been true in part because of what we knew and in part what we did not know. Now, what was known was discussed. Martin's many seminal contributions to science, including the Karplus equation in nuclear magnetic resonance spectroscopy, reaction kinetics of H plus H2, the hydrogen atom reacting with the hydrogen molecule, theories of protein folding and allostery, and the molecular dynamics of biomolecules. We discussed the science and its creation and its impact. And what was not known was discussed. When would Martin receive the Nobel Prize? Unlike most scientists that receive that distinct honor, not one but many scenarios were mentioned. A prize for contributions to the field of NMR before Richard Ernst was recognized. a prize for contributions to protein dynamics, perhaps with Hans Frauenfelder, a prize for molecular dynamics, possibly with Joshua Jortner and Ahmed Zewail before Zewail was recognized, and more. Well, that question was finally answered in 2013. But there were other questions. Was Martin investigated by the FBI? And if so, why? Martin was hired to the faculty at the University of Illinois with no journal publications in chemistry. What transpired in those years as a graduate student at Caltech with Linus Pauling, and in England as a postdoctoral fellow with Charles Colson? Martin co-authored the wonderful book, Atoms and Molecules, with Richard Porter, but it was rumored that there were notes for another book. Would that book be published in the future? Martin had established a tradition of changing institutions every 5 years, and he seemed poised to leave Harvard for France in the 1970s. And why did he stay at Harvard? And what happens during the summer when Martin is away in France? In Spinach on the Ceiling, these questions and many more are answered. Now, while biographies of great scientists are common, autobiographies are actually quite rare. And that makes this book and this moment of special significance. So Martin, we look forward to your remarks and our discussion.
Well, thank you very much, John. Let me also begin by thanking Jeff Meyerson and Lauren Artrillis and the other members of the Harvard Bookstore team for organizing this interview, and to you, John, in addition to the introduction, for being the moderator of this event. Like you, the Harvard Bookstore was a long time friend of mine, and I a friend of theirs. And we always, since the initials of my wife, Marcy, and my son, Misha, and mine are the same, we accumulate a huge number of points when we make our purchases there. So why did I write this autobiography? First, to try to inspire young people, particularly students in the sciences, by showing that even I met difficulties in my research, and importantly, that I had the faith to continue in spite of them. A striking example of this is actually the research related to my Nobel Prize. As John has already mentioned, I studied the simplest chemical reaction, an atom interacting with a biomolecule. I don't know whether it can make me bigger or not. Can one divide the screen? Is that possible?
Maddie, is that possible to change the view?
Sorry, yes, he is big. Full screen.
Yes, you appear in the full screen, I believe, on my computer.
I see. Okay. Okay, so as I was starting to say, one of the events that I was talking about had to do with the question of starting with, in the 60s, with the study of the simplest chemical reaction, an atom interacting with a hydrogen molecule. And I had the idea that I would try to extend this type of work to biomolecules, macromolecules that have not just 3 atoms, but hundreds or even thousands of atoms. And when I mentioned this to my chemistry colleagues, they said, well, we have a very hard time understanding how a small number of molecules behave in an accurate way. And so they didn't believe that this was what could be done. And when I mentioned it to my biology colleagues, they said, well, even if you could do it, it wouldn't be of any interest to us. Well, clearly history has proven them both wrong. Now, the lesson that students should take away from this is that if they have an idea that they think is important, they should have enough faith in themselves to continue working on it, even if their mentor or others say, well, this doesn't make any sense. Of course, they really should listen to their mentor once in a while. And the mentor may be right that what they're trying to do or the way they're doing it is wrong. And it's really this interaction between mentor and students, like John and I had, and many other of the Karplusians that he mentioned, that led to really a very productive atmosphere in my laboratory. And my feeling always was that once a student had shown that he could work on his own, that it was very important to let him do that and leave him alone, being available, however, anytime that he wanted to talk with me where he did have a problem and maybe I could help. Usually, though, the students who were very good went beyond what I actually had thought they might do. And this collaboration was really one of the great items that you gain when you are a professor at a university. And it's been wonderful. And John is just one of the examples of that. Now, secondly, I hope that my autobiography would bear witness to future generations of what happened in Austria during the Nazi period. As the then Mayor Häuptle, who was the mayor of Vienna, said when he inducted me as an honorary citizen of Vienna, and here I quote, "We cannot undo what happened, but we'll do our best to not let it happen again." And finally, in writing this, I wanted to record how fortunate I feel in having had such a great life so far, and also to pass on what happened in my life to my children and my other relatives. Let me now read a few passages from my autobiography. And this may take a little while because I have the autobiography here, which you can see. And I guess the front looks better than the back. And so I'll have to find each one. So the first thing I would like to mention to you, if you haven't already read the book, is where the title came from, Spinach on the Ceiling. Sorry, I'm having trouble finding it. Anyway, it's here it is. Then there was the infamous spinach incident. Mitzi, who was our maid and did most of the cooking around the house because both of my parents were working, Mitzi told me that I must eat spinach. Popeye did not exist in Austria, but unfortunately spinach did. With all the vehemence I could muster, I took a spoonful of the spinach and threw it at the ceiling. The spinach stain remained visible on the ceiling for a long time and was pointed out at appropriate moments when my parents wanted to indicate what a naughty child I was. Actually, nowadays, I love spinach, and we often have it as the vegetable. Now, one of the important aspects of my life when I was young, before we had to escape from Austria, was that we had a very large extended family and would spend summers together with them, either on one of the Austrian lakes or on the Adriatic. And there might be 20 or so people with aunts and uncles and cousins. And of course, my brother was always there with me. And if you get the book, I'm just looking at it, you can see the picture of my brother and me sitting in the foreground. And one day, what happened is the following. One day at the beach, it was in the early 30s, a friend of my parents picked me up and cuddled me, much to my dismay. I yelled, "Ich bin ein Nazi, I'm a Nazi," which so shocked her that she dropped me. Clearly, I had somehow realized, presumably from listening to my parents and others, that being a Nazi was the worst possible thing to do. This was, when I was a toddler. So it was, well, Hitler had already taken over Germany, but had not come into Austria yet, which happened in 1938. Now, one experience I want to mention is what happened when I worked in restaurants. I mean, one of the things, in addition to eating spinach and loving to cook, was that I spent a few weeks in various three-star restaurants in the kitchen. One of the best of those was in the kitchen of Joel Rebuchon, who was a three-star chef. In fact, he was the three-star chef in many ways, that he had gotten his 3 stars in 3 consecutive years after opening a little restaurant, and now had moved to a bigger one. And as my stage was nearing the end, it had been so special that I thought it would be nice to finish by having lunch there with Marcy. I was in Paris working in the kitchen, and Marcy, my wife, was in Strasbourg. I waited to request a reservation until a few days before, so not surprisingly, when I asked the maître d', he said he was sorry, but the restaurant was fully booked. However, he came back a little while later and said he had managed to find a table for us. Presumably, Robichon had intervened. Marcy had arrived from Strasbourg by train that morning, and we were ushered to a well-situated table with a bottle of champagne in a cooler waiting for us. Marcy's menu did not have any prices. This was not in itself unusual in an elegant restaurant where only the male, it was always the male in those days, of course, was given a menu with prices, and his guest did not see the prices. However, what was unusual was, however, mine did not list any prices either. I pointed this out to Marcy and asked her, what should I do? She said, well, it's pretty clear to me what's going on. Robuchon has invited us. It was a wonderful and gracious luncheon, at the end of which the Maître D' escorted us to Robuchon's private sitting room, where we had coffee and cognac with him and chatted for a while. It was really a great experience. Fortunately, Marcy and I were fluent in French because he didn't know, or he hardly knew English. When we then returned to Strasbourg, I sent him a special bottle of Odavi the Farm, which is pear brandy, for which Alsace was famous. He in turn sent me a letter thanking me very much for sending him this wonderful brandy. And Robuchon was not only a great chef, but also a real gentleman. And it was a wonderful experience in my life, though many of the other, I could go through all the other restaurants I worked in. But again, you can find that in the book. Some of them I worked in because the chef, Arzak, was interested in chemistry, in the chemistry of cooking. And so even though you normally had to wait several years to get a reservation in his restaurant, when he was informed that I was a chemist, invited me, and we spent some time together. Later, he hired a whole group of chemists to develop new ways of cooking things, details of which I won't go into. Now I want to describe an experience that resonates with what is unfortunately happening today in the United States. And my parents had given me their old car as a graduation present, and several times during my Caltech career, we lived and still live in Massachusetts. And so I would drive across the country to go home in Newton, Mass for part of the summer. Each time I took a different route, once through Canada, visiting Banff and Jasper National Parks, and another time through the Deep South. On one such trip, while driving through Texas on a very hot summer day, my friends and I decided to take a swim and cool off. We passed one designated swimming area that was full of people. Because we were unshaven and dirty from the long drive, we looked along the river for a quieter place to swim. About a mile downstream, we came upon another swimming area with broken down steps leading to the water. As it was deserted, we decided it was the perfect place for us. After we'd been in the water for about 10 minutes, a couple of pickup trucks drove up and several men jumped out with guns at the ready. They turned out to be the local law enforcement officers. They ordered us out of the water and demanded to know what we were doing. White folks swimming in an area reserved for niggers. They'd noticed the Massachusetts license plate on the car and had concluded we were northern troublemakers. After some effort, we finally succeeded in explaining that given our scruffy state, we had just as wanted to bother other white people, of course, The officers let us go with the admonition that we'd better drive straight through Texas without stopping anywhere, which we did. It was recently, a few weeks ago, I was reading a book called Caste by Isabel Wilkerson, which gives a profound description of the role of race in America today. She describes the role of the purity of water in the prejudice against African Americans. Whites were shot for going into pools reserved for African Americans, as well as the reverse. So really, it was, we were lucky to get away alive, I guess is the conclusion from that. Now, finally describe an experience from my graduate student days. I was Pauling's last student, as he generally only worked with postdocs and visiting faculty at that time. Linus Pauling, for those who don't know, was a very famous professor, won a Nobel Prize in chemistry, and then also won a Nobel Prize for peace in his work to stop atmospheric testing. And what had happened is that I had joined the group of Kirkwood, who was a theoretical chemist interested in statistical mechanics, and I'd worked for him for only a relatively short time when he decided that he would go to Yale, where was another very famous theoretical chemist, Lars Onsager. And all of his other students went with him, but Pauling said if any one of his students wanted to stay at Caltech, he would take them on as a graduate student, even though he was normally not taking any. So I accepted, decided to stay, which I think was a very good idea. So let me read a couple of passages from the book related to that. As I said already, but I'll read it. I was the only one to accept to stay at Caltech. All of Kirkwood's other students who had worked with him for a longer time decided to go to Yale. In retrospect, I think I made an excellent decision. I was to be Pauling's last graduate student. Initially, I was rather overwhelmed by Pauling. Each day upon arriving at the lab, I found a handwritten note on a yellow piece of paper in my mailbox, which always began with something like, "It would be interesting to look at so-and-so, so-and-so." As a new student, I took this as an order and tried to read all about the problem and work on it, only to receive another note the next day beginning in the same way. When I raised this concern with Alex Rich, one of my good friends, and other postdocs, they laughed, pointing out that everyone received such notes and that the best thing to do was to file them or throw them away. Pauling had so many ideas that he could not work on all of them. He would communicate them to one or another of his students, but he did not expect a response. Once I knew that, my relationship with Pauling became more constructive. Now, I still sometimes felt intimidated when I went to talk to him, but it was wonderful to work with him and be exposed to, although not necessarily understand, his intuitive approach to chemical problems. One day I asked Pauling about the structure of a certain hydrogen bonded system, namely whether the hydrogen bond would be symmetric in the bifluoride ion FHF minus. He paused, thought for a while. He always sat back in his chair and looked up at the ceiling and gave a prediction for the structure. When I asked him why, he thought again and offered an explanation. I left his office and soon realized, in part by discussing it with my circle of friends, that his explanation made no sense. So I went in to ask Pauling again, thinking perhaps that he would come up with a different conclusion. Instead, Pauling said he believed that the predicted structure was correct, namely that it was symmetric, but he proposed an entirely different explanation. After going over his analysis, I was again dissatisfied with his rationale and caught up with him as he was leaving his office. He produced yet another rationale. This one made sense to me, so I did some crude calculations that indicated that Pauling was indeed correct. What amazed me then, and still does today, is that Pauling came up with the correct conclusion, apparently based on intuition, without having worked through the analysis. He knew the right answer, news in quotation marks, even if it took more thought to figure out why. This lesson has stayed with me throughout my life, and again, is something that I use in some sense with my graduate students when I have an idea and I sort of think I know how to work through it, even though I haven't actually done it. I'm willing to say this is a good problem to work on. Well, let me end by saying that a discussion of my autobiography today seems to be, in some ways, not really relevant today when the United States and the whole world is faced with two dire threats. The rapid rise in coronavirus infections and deaths this fall, as everybody who watches the news is well aware. And secondly, the refusal of Trump and his entourage to recognize that Joe Biden has been elected as the next president of the United States. Thank you.
Thanks very much, Martin, for the readings and also the comments. We have a question from one of the attendees. I'd also like to encourage you, if you have a question for Martin, to please submit that through the Q&A. You'll find it at the bottom of your Zoom window, a tab for Q&A, and you can submit that question, and I'll be happy to pose that to Martin. This first question, Martin, comes from Zlatko Vasilkovsky, who is asking really two questions in one. What is currently the most important open question in chemistry, in your opinion? And also, what are you currently working on?
Okay, well, maybe I'll slightly change his first question, which is really more biochemistry than chemistry. And I would say that that is how the brain works. And then I mentioned that quite a few years ago, when I was much younger, I was interested in how the brain works and wondered whether what I knew how to do would actually be useful in trying to understand how the brain works. And I felt, I mean, that was actually one of the good things of having all these wonderful students. At one point, I had a group of 40 people, which is hard for me to imagine nowadays, knowing what everybody was doing. But it gave me the opportunity to spend some of my own time working on problems where I didn't have any idea whether I could make a contribution. And I spent several years looking at how the brain works and what one knew about that. In those days, one didn't know enough, and I decided clearly it wasn't the time to do so. Nowadays, I think with various techniques that have been developed, which can follow individual neurons and the interactions between neurons, that the brain is the most exciting problem to work on. And if I were 30 years younger, I would actually, that's the problem I would pick. Now, what was the second question?
Well, that's what are you currently working on?
Okay, yeah. Well, now what my group, which is not 40 people, but 3 people, what we're working on is trying to develop a flu vaccine. It was when we started on this, 2018 was the 100th anniversary of the big flu epidemic, which killed 55 million people. And the Gates Foundation put out a call for people to work on finding a vaccine that was universal for all the different strains of flu and permanent. As most of you know, you have to and you should get a flu vaccination every year. And it's very important this year to do it in particular. But the flu vaccination is not always that good because the virus changes so rapidly. And so you have to be vaccinated every year. And sometimes it's not very effective. So the idea is to find a universal vaccine that it works for the different strains of the flu virus and gives you at least maybe not a permanent, but a long time immunity to the virus. So that's what we're working on. And actually we've designed the antigens and everything, and people are just now trying to express them. And well, we'll see whether it works.
That's very exciting and timely, obviously. We have another question, which is, what was the experience of writing a memoir like for you when compared with science texts?
Well, I think it's similar in some sense that I'm not a facile writer. Going back to Pauling, I mean, he basically, his text, General Chemistry, he just dictated it and it was typed up and that was it.
Amazing.
When I write, I know what is good writing, but that doesn't mean that you can do it. And so my writing of papers with students is a long back and forth process. And many of the students have been unhappy that it took so long to get a final draft of a paper, which I was willing to submit. Some of them have then carried on and done the same thing with their students. And basically writing my autobiography was similar in that sense, that I would sort of start writing things and and then go over them. Marcy, my wife, read over it and made many comments on them. And it was really an iteration that was involved in writing the autobiography. Iteration with multiple steps, similar to what happens in papers. Of course, I had to sort of remember things from my past that I hadn't thought about for a long time, and also dig up documents that the family had kept from being in Austria and such. But it was in many ways a similar way of writing.
I see. That's great. I know I mentioned in the introduction that you didn't have papers published in chemistry or molecular science when you were hired at the University of Illinois, but you did have two publications related to your work as a naturalist that you discuss in your book, and bird watching. And I was wondering if is that something that you have continued to have an interest in throughout your life, or birds and the avian world?
Yeah. Well, the answer is yes. Well, in the sense that for a long time I went on bird walks. Nowadays, when I go hiking in the woods, I always have my binoculars with me, and I'm bird watching, but I'm not doing it seriously, going on trips with people or anything like that. The last thing that I did actually was, I don't remember the exact date, but when I went to Texas and visited one of my former students, Monty Pettit, one of my requirement to come there and give a talk was that we would go out in a boat and watch the whooping cranes, which were not at all afraid of people, and you could really get close, and that was really a wonderful experience. That's the last time I did sort of real bird watching.
That's excellent. I'd be happy to take more questions from the audience. Please feel free to submit those. Martin, I have a question for you that has to do with another remarkable and influential scientist, Steve Barry. And I saw that David Oxtoby was among the participants, who was a colleague of Steve's at the University of Chicago for many years. Steve recently passed away, but he was a contemporary of yours at Harvard College, and I understand that you had other things in common as well. Part of that you discuss in the book, that you were best boy in the Westinghouse Science Talent Search in 1947, and Steve was a finalist the following year. And we read in your book about your life as a chef, and you discuss that in your comments. But I understand that eating contests were held among Harvard undergraduates at the time. Steve mentioned that to me, and that you performed very well. And I'd like to know, is that a true story?
Well, he probably is talking about Durgan Park, which was a restaurant that I think was established sometime in the 1700s. And they had roast beef was one of their special dishes. And Steve and I went there, and basically you could go there and you paid, I don't know what it was, but you could get all that you could eat. So indeed, we did have eating contests. There were other ones that happened in other places. In one place where I went, where was it all that you can eat place, and I kept eating and eating, and at a certain point, the chef came out with a knife and sort of said, "This is enough. I think you'd better go home and never come to my restaurant again."
Amazing. Excellent. So we have a few questions from the audience. This first is from Jerry Gechter. Says, you talked about how no one was originally enthusiastic about what became of your Nobel Prize work. Could you say more about how their points of view proved wrong? So I think that's the different views of the H+H2 work that you described earlier, and then the protein dynamics.
I'm not quite sure what the question is. Is he asking, why was my Nobel Prize delayed so long? Is that?
I think it's more, I think in your comments you mentioned how the work that you were doing was perhaps not appreciated by biologists and also perhaps by people working on smaller molecules. And so if you could explain how it was that they were wrong or didn't see the significance.
Well, I mean, it took quite a while for people to realize the significance that the calculations, the molecular dynamics of biomolecules was very important. I mean, initially, we were doing it just to try to understand how the biomolecules worked, how enzymes worked and such. And then as time went on, the pharmaceutical companies and others became interested in doing these simulations to find atoms or molecules that bind to some protein that you want to inhibit. And also, as my group, in order to developed a program they called the CHARM program, which is now widely used in industry. And it's an interesting point why we actually, or why I decided we should have a program, because I guess, I was going to say my group, but I am not really that well organized. And often when a student left, what he had done sort of disappeared because we hadn't been careful to record it. And, the computer program or something said it disappeared. And so it was at that point I decided that we should have a program which was for our use, where we would put in everything that had been developed by students working on biomolecules. So it was also used for small molecules. And that after it had been checked, it would be kept in there. So that was a way of really preserving the history of the developments of the group. It later turned out, as I mentioned earlier, that other people were very interested in using the program, and we then made it available to the public. And like now, there's several programs, similar programs available, which are very widely used by pharmaceutical companies. And maybe it was some of that the Nobel Committee was waiting for. I don't know. If some of as some of you may know, the documents of the decisions of the Nobel Committee are open 50 years after the prize is given. So some of you, if you're young enough, may be around then, and we will be able to read about what came up when my name first came up, what made them decide that this was the time to give the prize. And
I'd recommend the Nobel Prize Archive as an excellent site to visit and resource, and speeches that are archived there. And now with videos, you could watch Martin's acceptance speech, for example, which is quite wonderful. It's a great resource, highly recommended. So an anonymous question. I would like to hear more about how Professor Karplus became a photographer and what inspires him about photography.
Well, I never took a course or anything in photography. At first, in a way, it had a little bit to do with bird watching, that I really liked looking at nature more generally, and decided I wanted to record it. And when I went up to Alaska as an undergraduate at Harvard, I had the opportunity to go up there. I borrowed my mother's camera and took a whole set of pictures, which I still have available, which have been shown, of Eskimos and polar bears and such. And then when I had gotten my PhD and was getting ready to go to Europe, my parents gave me a Leica camera, which is a wonderful camera. And it's very light, and it takes very high resolution pictures. Of course, in those days, it was all film rather than digital. And when I was a postdoc, I took my, what it says I had a National Science Foundation fellowship. What it says is that you should follow the customs of the institution. Now, at Oxford, where I was working with Charles Coulson, as has been mentioned, basically the students spend 8 weeks term time in college, and then have 6 weeks vacation in between. What normally happens is that the 8 weeks are spent having a good time, and during the 6 weeks, they actually do, when students go home or whatever, they do their work. I, however, spent the 8 weeks in college or in Oxford, and during the 6 weeks, I drove around Europe. I had bought a Volkswagen Beetle with Gary Felsenfeld, a fellow student of mine, and we drove all over Europe. And I had this wonderful camera, and I just started taking pictures. And it was sort of for myself, and it was only later that the pictures were printed by somebody in Oxford who said, gee, these are really great pictures. You should exhibit them. And so at that point, I became a real amateur photographer. Basically, I didn't realize it. Again, Marcy was responsible for getting printed a set of photographs for an exhibition for one of my birthdays. And the person who did the printing is the one who said, you're really, you should show your photographs to the world. And that's how it began.
I see. So the photos that you took in Yugoslavia that are part of the Remember Yugoslavia exhibit that you told me as we were preparing for this event are still hanging in Adolphus Busch Hall on the Harvard campus, and possibly might be open for viewing after they reopen. Was that during that time that you were a postdoc that you made that visit?
Yes, yes.
Okay.
I drove down from England, went to Europe, and then drove down through Yugoslavia to Greece. And it was a very interesting trip. I don't remember right at the moment how much I describe it, but basically there were no tourists in Yugoslavia in those days. There were no gas stations except every so and so many miles, and you had to plan your trip so that you had enough gas or you had an extra tank to be able to go from one place to another. It was quite an experience.
Amazing. Yeah, you captured that country at a really remarkable time. Of course, no longer exists in that form. I know we're approaching 6 o'clock. There's another question here from Prabhu Raman, who asks, are there any scientific developments in the subject of computational chemistry that you did not anticipate many decades ago?
Well, I guess the most obvious one is quantum computing. I mean, I never thought of that many decades ago, and it has, in principle, it can really make computers orders of magnitude faster. In practice, so far, it's not really been developed to the stage where it's useful, but it probably will be. And I would say that's the most important development that I never thought of.
That's a perfect point. I think probably at that time in the early 60s, I don't know if anyone was thinking of quantum computing.
Yeah.
Yeah, but a lot of remarkable potential. Are there any other questions as we close? I think it's probably time to conclude the event, and I see Maddie is back on here. So thank you very much, Martin, for the reading and also answering the questions from the attendees.
Yeah, huge thank you to both of you, Martin and John, for a wonderful night in. And thanks to all of you out there too for spending your evening with us. You can learn more and purchase tonight's book, Spinach on the Ceiling, through the link in the chat box. And on behalf of Harvard Bookstore here in Cambridge, Mass, have a good night, keep reading, and please be well.
Yeah, thank you, Maddie. Thanks to the book.
Thank you.